Alright, so this is the first thing I'm doing with my new tablet, and let's see how this looks. So what we are looking at now is section. I could do that a little bit thinner. Let's see how this goes. Let's do that. Great. Okay, so this is in section 4.4, and we are looking at basic matrix operations. I'm just going to abbreviate that, ops. So basic matrix operations. And so what are the basic matrix operations? Well, we can do a lot of the same basic things that we can do with numbers. We can add, and we can subtract, and we can multiply. And there are actually two different sorts of multiplication that we're going to be looking at. But let's start off with addition and subtraction because those are really the simplest. So let's say this, addition. To add two matrices, first of all, they have to be the same size. So they have to have the same number of rows and the same number of columns. And second of all, what you do is you add them entry-wise, and I'll explain what I mean by entry-wise in a second. Okay? Okay. Now let's see if I can clear this this entire thing. Oh, I can clear. Okay. So add entry-wise. Great. So what does this mean? Let's just display this via an example. Let's take, say, 1, 8, 7, 2 plus 4, 6, negative 3, negative 5, something like that. Well, these are both 2 by 2, so it's cool to add them together. And what is the result? When I say that I add them entry-wise, I mean that I add together corresponding entries. So I add 1 and 4, and that will be my first entry in my first row. I add 8 and negative 3, so that's 8 minus 3. Now it will be the second entry in the first row. The first entry in the second row is 7 plus 6. And the second entry in the second row is 2 minus 5. And so what I end up with then is 5, 5, 13, negative 3. And notice that even though it's addition, some subtraction is happening inside of here. The two matrices are being added, but some of the entries might be being subtracted. So let's just do maybe a couple more examples of this. So let's say, now I'm going to add, say, 0, 1, 3, 0, negative 1, 2, to 4. It's still happening. I think it's just because I'm doing so many programs at the same time. Okay, so 4, let's see, negative 3, 0, 2, 1, 4. Why not? Okay. Now these are both 3 rows down, 2 rows across, so they're both 3 by 2, so this makes sense. And so the sum I get is, I'm not even going to bother writing it out as explicit as I did this time. I get 0 plus 4, which is 4, 1 minus 3, which is negative 2, 3 plus 0, which is 3, 0 plus 2, which is 2, negative 1 plus 1, which is 0, and 2 plus 4, which gives me 6. Okay. Great. Now this is especially useful, or will be sort of useful, I suppose, when we're looking at row and column matrices. In fact, it's probably a little bit more obvious when I'm looking at, say, a row matrix. Excuse me, a column matrix. When I'm adding two column matrices, these are both 3 by 1, I basically just add across. 1 minus 2 gives me minus 1, 0 plus 1 gives me 1, 3 minus 8 gives me negative 5. That's pretty easy. When I'm adding two row matrices, maybe it's best to think of it as, so this is a 1 by 4 row matrix. Maybe it's best to think of it as adding down. So 2, 0, negative 1, 5. So I could think of this as adding just down. Negative 3 plus 2 is negative 1. 2 plus 0 is 2. 1 minus 1 is 0. And 0 plus 5 is 5. So, great. In the result in each of these cases, notice that the result for everything that I've written so far, the size of the matrix is always the same. I add two matrices of the same size, and I end up with a matrix of the same size. Great. How about subtraction? Well, first we can talk about the negative of a matrix. Just as we can talk about the negative of a number, we have the negative of a matrix. And to get the negative of a matrix, all I do is I just change the signs of all entries. That's it. So for example, if I took the negative of 2, 1, 5, 4, I will get negative 2, negative 1, negative 5, and negative 4. Okay. If I were to take the negative of, let's say, 1, 0, negative 1, 2, 3, negative 4, I just change the signs. This is supposed to be 0. So I would get negative 1, the negative of 0 is 0, and negative 1 becomes positive 1, 2 becomes negative 2, negative 3, and 4. Great, so those are the negatives. So then subtraction I can think about two different ways. One is sort of just the obvious way. Again, the matrices need to be the same size, but I don't know. It's up to you. Let's suppose I have 1, 0, 3, 2. I'm going to subtract 2, 4, 0, 8. Well, one thing you can do is just take 1 minus 2 and get negative 1, 0 minus 4 and get negative 4, 3 minus 0 and get 3, and 2 minus 8 and get negative 6. Just subtract component-wise. But the other way that you can think about it, if this helps you out, is you could think of it as when I subtract a matrix from another, I'm really adding the negative of the second matrix. So I can also think of it as 1, 0, 3, 2 plus the negative of that other matrix, which is negative 2, negative 4, 0, and negative 8. And then go ahead and do the addition and you get the same thing. I'm not going to bother writing it down again. Okay. This could be useful if you're looking at things like, let's say I've got 1, 2, 0, negative 1, 3, 4. And let's suppose I'm subtracting 2, negative 3, negative 5, negative 2, 1, 0, something like this. It could be easy to forget that when I'm subtracting, say 2 minus negative 3, that is really 2 plus 3. So maybe it's smart to change everything into its negative here, just to make it a little bit easier to add. Then I get 1 minus 2, which is negative 1, 2 plus 3, which is 5, 0 plus 5, which is 5, negative 1 plus 2, which is 1, 3 minus 1, which is 2, and 4 plus 0, which is 4. Maybe that's a little bit easier to do. Subtraction. Now, what happens if I subtract a matrix from itself? Well, let's consider subtracting a matrix from itself. Let's take, just 2, 3, 1, 4, and I subtract 2, 3, 1, 4. What do I end up with? I guess it's not a big surprise. 2 minus 2 is 0, 3 minus 3 is 0, 1 minus 1 is 0, and 4 minus 4 is 0. Well, we call this the 2 by 2 0 matrix. Now, generally, for any size m by n, we have a 0 matrix. And all it is it's the matrix which has nothing but zeros in it. So I could have the 2 by 3, or excuse me, the 3 by 2 0 matrix looks like this. I could have the 2 by 4, 0, 0, 0, 0, 0, 0, 0, 0. These are 0 matrices. Here is the 0 column matrix with 3 rows, and here is the 0 row matrix with 2 columns. Great. And the 0 matrix satisfies some typical properties. So let me denote the 0 matrix of any size by 0, just so I don't have to write it down each time. Then, for any matrix, I'm going to write it with a capital letter. Let's write X. For some reason I like that as maybe a name for a matrix. X plus 0 is equal to X. X minus X is equal to 0. Okay, that's what we really expect. So, hooray, 0 matrix. Okay.